How you doing, everybody? How's the day going? It's your boy Joe coming at you once again. Hey, we say hi to me. You stole my man.
You really exotic, that guy in the money.
Oh my God, crazy. It's a Molly up in here. Double tap. And double Debbie Dad. Double Dad. How's everybody? I doing today? Hope everybody's having a good day.
Serious and we're gonna kick some butt today. Alright? I know yesterday I kind of disappointed everybody by not having enough energy to get the stream, and I'm so sorry for that. But today I've been drinking. It's going out of style, and I'm full of energy, and I need you guys to that way we can get through some IPv4 addressing and some subnetting. Alright, enough of this madness, Joe. Enough of the madness. Let's get to it.
All right, my regular voice is back now. See you later, characters. What's up, Tech Geek? How we doing? Welcome to the stream, my friend. We're going to be going over some IPv6, subnetting, and some addressing today. It's going to be fun. How you doing today? I'm going to drop that down. All right. Let me move my screen. Boop. All right. Good, I've been having IPv6 issues. LOL. Maybe this might help me fix it. IPv6 is a fun. It's fundamentally so much like IPv4, but there's a lot of there's nuances to it because a lot of things had changed. A lot of the processes had to change to support IPv6, obviously. Because of how it differs from IPv4. So, yeah, I hope this. Let me just close my door real quick. Hold on. Hey, yeah, I hope this. Let me just close my door real quick. Hold on. Hey, yeah, I hope. Oh snap! Thank you for the follow, Tech Geek. Awesome, man. I appreciate that, my friend. Awesome, man. I appreciate. I'm glad I caught that real quick as I was walking back in. All right. So, let's change up some sceneries here. And let's change up some sceneries here. All right. So, we're going to be diving right right back into where we were. So we're gonna be where we were yesterday. Right back into where we were. Silent that. Where we were yesterday. Oh boy. Right back into where we were. Silence. All right. My bad for that. All right. So, IPv6 addressing and subnetting. We're gonna be getting. We kind of reviewed this yesterday, so I'm gonna get down to where we pretty much were, where we ended off. All right. It was right about here when we started talking about global unicast. Now, Tech Geek, just real quick, what kind of issues are you experiencing and stuff like that? Just to give me like a quick synopsis, like is it addressing, is it routing and stuff like that? Since we're talking about IPv6, that kind of pertains to the conversation today. So yeah, so if you want to elaborate, you don't have to, but if you want to elaborate, I'd be definitely interested in discussing some of it today. So all right, just throwing that out there. All right, so some key topics we need to go over. All right, so we have global unicast and unique local. So when we hear global unicast, again, like we talked about yesterday, that's what we think about in the public domain. All right. When we think unique local, we're thinking private. All right, private. All right. So let's read some of the key terms here. So global unicast, addresses that work like public IPv4 addresses. The organization that needs IPv6 addresses asked for a registered IPv6 address block, which is assigned as a unicast, which is assigned as a global routing prefix. After that, only that organization uses that address inside of that block of addresses. That is the addresses that begin with the assigned prefix. Okay. So again, pretty much like how IPv4, when a company went to the registry there and they asked for a block size of IPv4 addresses, that same concept is being used with IPv6. So they have to go ask for a block of addresses, and then that company is solely assigned that chunk of address ranges that they then get to assign their hosts, their network devices, and so on and so forth. One thing I did learn about IPv6 today is there is no limit. As long as you have and this is only in the I guess in the enterprise level. Like at home, we still would be using NAT stuff like that. Like when I start doing IPv6 routing and stuff like that on Cisco Modeling Lab and whatnot, I'm still gonna have to set up NAT and PAT just because of how it's my home router and stuff like that is set up. How it's still using IPv4 for its routing protocol to my internet service provider. All right. So and I'm only referring to that when we set up like an external port out to my actual home internet and stuff like that. I believe my home router is using. I believe it probably is using. No, it isn't. I don't think it is. But that either way, whatever. Saying it's connected to the internet, but not allowing me to internet access. Not allowing me to. So did you statically assign that IPv6 address? I'm just asking. Did you statically assign that IPv6 address to your host or your network device or whatnot? Or did that address be assigned to that device via DHCP? Those are two things that will help us kind of troubleshoot where you're having issues. Because if it's a DHCP issue, then you may have to log into your router there or your DHCP server wherever your DHCP server is, and you'll have to take a look to see if that address range is falling within the correct correct routable addresses there. Unfortunately, I didn't set it up. I didn't think to check that, honestly. Very new to this. All right, yeah, so that's a good, and that's a good thing to bring up, because there is a couple of things that may cause that particular thing to happen. So you have to take a look. So again, is IPv6 being used at that router? So is the quote unquote whatever your gateway is that obviously it must have assigned that device. So there must be some DHCP server dynamically assigning IPv6 addresses. You have to get into that gateway, that router or whatnot, and take a look at that, and take a look at those parameters there, and then see if it's actually correctly assigning addresses. Now, is there other devices connected to that same gateway that are working correctly? That's another thing. If there's other devices that are connected to that same exact gateway, take a look to see if those are working correctly. And if those devices, if say those devices are actually using a different gateway, then you might have picked up a different default gateway by, for instance, a different DHCP server gate by accident, and it may have assigned you an address. Yeah, this is the only connection not working. But all connected to the same gateway though. That's just one thing just to take a look at. Look at the default route on, say, like, take two devices, take the device that's not working and take another device that is working. Make sure that take a look to see if they both are using the same default gateway address. And if they are, then we can go into another possible scenario. But if they aren't, say if they aren't using the same gateway, oh snap! Thank you so much for the follow, ABC Win! 321 viewer! Oh, you rated me? Oh man! You pumped me up right now! Good looking out. I appreciate that, my friend. Woo, 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 woo. What's up, ABC Win? How we doing, my friend? Welcome to the stream. Talking about some IPv6, some subnetting, some addressing. Oh snap! Just finished the study session. Of my wait. What's OYW? Give me a little content. Give me a little why is this thing? Hold on. There it goes. Just give me a little bit of context sensitive help with OYW. I would love to know. Yeah, anytime, tech geek. Anytime, man. Anytime. Like I said, oh, got my butt kicked by a CDP lab. Ah. Nice. Where are you labbing it up? Are you labbing it up in Packet Tracer or GNS3 or Cisco Modern Lab or anything? All right. Let's kind of get back to what we were talking about. So, and guys, again, just continue to comment and stuff like that, and periodically we'll Packet Tracer. Nice. I love me some Packet Tracer. Was this did you get the lab from like Udemy or like off of like one of David Bumble's type things, or did you get it off of like the actual Cisco LearnNet there? All right. Unique local. Unique local works somewhat like private IPv4 addresses with the possibilities that multiple organizations use the exact same addresses with no requirements for registering with any numbering authority. All right, so that's again for us to use a unique local. Neil Anderson's Udemy course. Nice. Neil Anderson. I think I actually bought his Udemy course as well. Because I remember I ended up purchasing David Bumble's, and I believe it was Neil Anderson's one too in the beginning of my adventure into all this. That's awesome. That's awesome. I'm glad. So are you going after CCNA too? ABC WAN. So again, to use unique local, we would still have to use NAT and PAT to be able to reach out to the internet. Because of which, again, it goes back to the idea of private and public IPv4 addressing, all right, where your home gateway, your home router has a assigned IP address from the ISP, and that home router, your home gateway, that's what I'm talking about. Woo woo woo. Well, hey man, that pumps me up. That you're going after the CCNA. It's in a great. That's what I'm going after. I mean, Tech Geek. I don't know if you're. I mean, I know you kind of said earlier that you're kind of new to this. But this stream and stuff like that is revolved all around going after CCNA certifications, and ABC. That's awesome, man. That pumps me up. The CCNA certification is such a great certification, and I tell everybody that fundamentally, anybody who's into like IT and stuff like that, it covers such a broad scope of pertinent, and I'm saying pertinent information and skills, lots and lots of skills, because it's a certification that requires you to get into labbing, and it teaches you the how to lab, the way to lab, and the thing is, it branches off way past networking too, especially when we start gonna get into Linux and stuff like that, Linux servers. You know what I'm saying? It gives you the fundamentals of, okay, this is how I structure a lab, and this is how I can lab things up so I can teach myself more and more, and it gives me that hands-on experience to get better at all things IT. And that's why I've fallen in love with the CCNA cert. Who are you getting your CCNA cert through? So I'm just gonna register for the test. I'm not going through a particular school or anything like that. I mean, I'm in college and stuff like that. I'm going after a bachelor's degree in IT, but that's not part of the CCNA. Oh snap! Who do we got as a follow? Let me look at my thing. Hydrant Camp 1. Good looks on the follow. Woo woo. Welcome to the stream, my friend. So what I'm using here and what you guys, I have a subscription to O'Reilly Media, and I suggest if you're into things IT, a subscription to O'Reilly Media. It's an expensive subscription. It's a lot expensive than your Netflix subscription. But I strongly, I'll be the first one to tell you it has given me the ability to gain so much knowledge, because not only do I have the availability to look up anything I want to look up or read a book about anything that I want to read that have been published by things like Pearson, Cisco, so many other big tech companies. It also gives me insider knowledge into AWS, Microsoft Azure. I get to take live courses by people who are experts in these particular fields, and actually talk to these people who are in the trenches of doing all things IT, from Python to Java to things that might make my brain explode when it comes to creating um, like an AI intelligence type programming and stuff like that. But yeah, so that I guess to answer your question, I'm not per se going through a particular organization to get it. I'm just going to register for the course through Pearson and then take the certification. ABC WAN, I'm pretty sure you're probably doing the same thing where you're self studying yourself, and you're going to be just registering for the certification once you're comfortable and well, you might have already registered for it. I think we might have talked before ABC WAN, but yeah, so I'm hoping to go after these certifications by late February, hopefully late February, because I want to get in, because I also want to register for the DevNet exam as well, and I want to be part of that DevNet 2020 class. As corny as that might sound, I have till February to register for it. I believe I have till February to register for it to be still part of that DevNet 2020 class. So, yeah, that's kind of it. Great question. All right. Take a sip of my coffee. All right, IPv6 global routing prefix. IPv6 global unique addresses allow IPv6 to work more like original design of IPv4 internet. Each organization asks for a block of IPv6 addresses which no one else can use. Again, just like we were to do in IPv4. Okay, that organization further subdivides that address into smaller blocks called subnets. And, again, fundamentally still the same. Finally, to choose what IPv6 addresses to use for any host, the engineer chooses an address for the right subnet. And I was actually asked this question a couple of days ago. Why would you subnet an IPv6 network? So, I guess my response and my answer to that is because fundamentally you still want to approach how I guess you're looking at IPv6 as you were to look at IPv4. So, if you're separating things via a router, or you have different departments and stuff like that, I guess to kind of keep things organized, you would do that, and kind of keep it into that same mindset as you were. All right. That reserved block of IPv6 addresses, a set of addresses that only one company can use, is called a global routing prefix. Each organization that wants to connect to the internet uses a IPv6 global unicast address. Global unicast should ask for the received global routing prefix. Very generally, you can think of the global routing prefix like an IPv4 class A, B, or C network, numbered for the range of public IPv4 addresses. The term global routing prefix might not make you think of a block. The term global routing prefix might not make you think of a block of IPv6 addresses at first. The term actually refers to the idea of the internet. Internet routers can have one route that refers to all addresses inside the address block, without a need to have routers for small parts of that block. For example, in the figure shows 3 companies with 3 different IPv6 address routing prefixes. The router on the right, R4, has 1 IPv6 route for each global routing prefix. All right. So this is just company 2001 DB8 111 222 333. All right, and then it's just showing the prefix slash notation of 48. Okay, pretty much stating, and we went over this the other day. So if we had in this address, we'll fully write this address out. Let me just make this actually smaller. we'll make that smaller. So if we were to write this complete address out, we got 2001 colon 0 db db8 colon 1111 colon what's that 123 1000 0 0 0 0 1 2 3 4 5 1 2 3 4 4 1 2 3 4 5 6 7 8. Okay. So again, if we were to write this address out, this is that full address here, guys. Okay. All right. So this would be our complete, at least for company one. So this would be their full IPv6 address written fully out. Okay. And then they're annotating. They have the /48 prefix. Okay. So the /48 prefix. Oh wait, my big old head is in the way of that, isn't it? Oh, no. Just hide that real quick so you guys can see what I'm talking about. I forgot. Sometimes I forget that's in the way. All right. So if we were to find the 48, so remember, so each field has 16 in it. Okay, so each field has 16. Is holding 16 bits in it. Okay, 16, 16, 16, 16, all right, 16, so on and so forth. Okay, so if we need to find 48, so we got 16, 16, 32, all right, plus another 16, that gives us 32, 32, yeah, that gives us 48, right? Yep, that gives us 48. So the portion of their prefix would be 2001 db8 111 1 1. All right, so 2001 colon 0 db8 1111. All right, so that is their prefix length and everything else. So this is all their host. So this would be like their ability. So they'd be able to subnet out this rest of these bits right here what's inside of their internal network. Okay, and this is why obviously this is why we've moved into IPv6, because of how large IPv6 is. It's extremely large. Okay, remember when we talked about it, we have 10 octillion addresses, all right, in an IPv6 address block. 10 octillion. I mean, that'll break your brain when you're thinking about it. Okay. All right. So again, to get into the discussion of what this is talking about, all right. This router here, all right, knows. So it's pretty much. So again, the term global routing prefix might not make you think about a block of IPv6 addresses at first. The term actually refers to the idea that that the internet router can have one route that refers to all addresses inside the address blocks, without the need to have routes for smaller blocks of smaller parts of that block. For example, in the figure shows 3 companies with 3 different IPv6 global routing prefixes. That router on the right has one IPv6 route for each global routing prefix. Okay. All right, so it's just like inside of its routing tables here. Okay, it's routing tables. All right. Get rid of that. I get rid of that one. Where's my viewer count? Bloop. There you are. Silly Billy, silly Billy. All right, let's move on. All right, the routing, the global routing prefix sets those IPv6 addresses apart for use by that one company, just like a public IPv4 network or CIDR. So classless inter-domain routing, classless inter-domain routing, CIDR. Okay, block does an IPv4. All IPv6 addresses inside the company should begin with the global routing prefix to avoid using other companies' IPv6 addresses. No other company should use IPv6 addresses with the same prefix. And thankfully, IPv6 has plenty of spaces to allow all companies to have a global routing prefix with plenty of addresses. Okay, both IPv6 and IPv4 addresses assignment processes rely on the same organization, the IANA and the ICANN. All right, the Regional Internet Registry, IRR, yeah, that'll mess you up. And the ISP, so your Internet Service Providers. Okay, for example, in an imaginary company, company one receives the assignment of a global routing prefix. The prefix means all addresses whose first 12 hex digits are 2001, yada, 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 0, Delta Bravo 8, 11111, as represented by the prefix 2001, 0, Delta Bravo 8, 11111, ::/48. To receive that assignment, the process is shown in the figure here, okay? So the IANA, all right, the IANA reserved, all right, gave a chunk of addresses to the IRIN, all right, that's the North American Registry, gave it the block of the 2001. So there we go. So that's where we got the 2001, all right, block from, all right. Then the ISP went to the North American ARIN, and then they got the block of the 2001 0 Delta Bravo 8. So the ISP is like, okay, now I have this block that I can, register out. So then company one says, hey ISP, I need a block of IPv6 addresses. Can you hook me up with a block? And they said, okay, well I have 2001 0 Delta Bravo 8, in your company one, so I'll give you the prefix 11111. All right, company two, company three, yada yada yada, and then so on and so forth. And then when company one gives out an address, they're going to say 2001 :0 Delta Bravo 8 :1111. Okay, now this is when they start subdividing these addresses out. All right, they're going to say, okay, now I have maybe 0001, and I'm going to give that to something, 0001, 0001, 00001, and whatever, and continue on, same thing. Again, I'm just elaborating on how this this scheme, not scheme, but how this concept is working. Okay. All right. Again, 0002. Too many zeros, Joe. 0002. And then, obviously so on and so forth. All right. So as long as that company one there, all right, is maintaining their prefix, okay, all right, then they have, again, all those addresses in those other quartets, not octets, IPv4 quartets, all right, is what the terminology we'll be using in IPv6. So the quartets, so we have 1, 2, 3. So the last 5 quartets here, all right, so there's 5 other quartets that they can subdivide out. And now that's a humongous range of addresses, okay? Humongous range of addresses. They'll never run out of that. I don't care how big your company gets. Well, I mean, I guess we can figure out a way to scoop up all those addresses by giving everything that can, we can give every pen in the office an address, and then we'll eat up all those addresses. So that's, again, and then company two would do the same thing, but it'd be obviously 2222, company 3, 3333, so on and so forth. All right, we have the idea. All right, prefix assign it with the IANA and the other registries and the ISPs. The event in the figure uses left to right flow. In other words, the event on the far left must happen first, followed by the flow to the right. So obviously, yeah, left to right. Cool. All right. The IANA allocates the ARIN prefix 2001 ::/16. The IANA for the allocation of the large block in the imaginary example. The IANA, yep. Okay. Again, and then the IRAIN allocates to the ISB the other prefix, the 2001 : 0 Delta Bravo 8 : 32. And then the ISB then assigns company 1 the 2001 0 Delta Bravo 8 : 1111 : /48. All right, address block. Okay. All right. So we have the concepts. If there's any questions on that, again, I will gladly go over it again. But for the most part, that's pretty well, I don't want to say self-explanatory, but it's a pretty easy concept to grasp. All right. Again, where it's taking the steps on how these prefixes are being allocated out, how these blocks of addresses are being allocated out. Okay. All right. Note, if you do not plan to connect to the internet using IPv6 for a while and just want to experiment, you don't need to ask for an IPv6 global routing prefix to be assigned. Just make an IPv6 address and configure your device, or use a unique local address as discussed towards the end of this chapter. So again, once we get into unique addressing and stuff like that, we're going to jump over to Cisco Modeling Lab, and we're going to start labbing up some IPv6 connectivity and making some routes and stuff like that, and some connections, and seeing if we can ping devices using IPv6. All right. Address ranges for global unicast addresses. Global unicast addresses make up the majority of the IPv6 address space. However, unlike IPv4, the rules for which IPv6 addresses fall into which category are purposeful and more flexible than they were with IPv4. And the rules for IPv4, the class A, B, C, D, and E. Originally, IANA reserved all IPv6 addresses that began with the hex 2 or 3 as global unicast addresses. This address range can be written pretty much as the prefix, 2000 : 3. All right. Later, the IANA made the global unicast address range wider, basically to include all IPv6 addresses not otherwise allocated for other purposes. For example, the unique local addresses discussed later in this chapter all started with the hex X FD. All started with the hex FD. All right. So while global unicast addresses would not include any addresses that began with FD, any addresses and any address ranges that are not specifically reserved for now are considered a global unicast address. Okay. Finally, just because an amazingly enormous numbers of addresses sit within the global unicast addresses range, IANA does not assign prefixes for all over the address range. IPv4 has survived well more than 30 years with the admittedly too small addresses size because of the IANA has adopted good practices to conserve the IPv4 address space. Because making smart and practical choices in assigning IPv6, the IPv6 addresses should space could last much longer than IPv4. So again, I feel as though IPv6 will get us into the space age. And what I mean by space age is when we're intergalactic beings living on Juniper and Mars and whatnot. Juniper, I said Juniper. I don't think we're ever going to live on Juniper. Juniper. I'm calling it Juniper now. I can't even say. All right. So here we go. Address types. First hex digits, global, 2 or 3 originally, or all not otherwise reserved today. Unique local, FD. Multicast, FF. Link local, FE80. All right. And if we were to, let's go, if you're not familiar with hex, we can kind of give a, yeah, we can, I'll see if I can remember. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have A, B, A, B, C, A, B, C, D, E, F. All right, and obviously what these are representing. All right, so this is 10. All right, 11, 12, 13, 14, and 15. Okay. All right, so that's hex. That's a quick representation of hex. So when we see the FF, so that's hex. So that in, how do I explain that? That in equals in decimal 15, right? Something like that. But either way, this is obviously the numbers for oh wait, I forgot 0. So it's 0 as well. Okay, so 16, okay, including 0. Gotta include 0, okay. So that's the hexadecimal. So the multicast right there, pretty much equals like 15, 15. All right, that's the quick breakdown to hex right there. All right. Let's continue on. IPv6 subnetting. Want to become famous? No. I hate these thinking things. Get rid of that message real quick. Those things are a pain in the butt to get rid of. How do I get rid of that? I'm not gonna mess with it. All right. Let's go back. All right, let's get back to it, guys. All right. After an enterprise has a block of reserved global unicast addresses, in other words, a global routing prefix, the company needs to subdivide that large address block into subnets. Subnetting IPv6 works generally like IPv4, but with mostly simpler math. Hooray! Because of the absolute large number of addresses available, most everyone uses the easiest possible IPv6 prefix length, the /64. Using the /64 as a prefix length for all subnet makes the IPv6 subnetting math just as easy as using the /24 mask for all IPv4 subnets. In addition, the dynamic IPv6 addresses assignments process works much better with the /64 prefix length as well. So in practice and in the book, expect IPv6 designs to use the /64 prefix length. This section does walk you through the different parts of IPv6 subnetting, while mostly using examples that use a /64 prefix length. This discussion defines the rules about which addresses should be in the same subnet and which addresses need to be in a different subnet. Plus, this section looks at how to analyze the global routing prefix and associated prefix length and find all IPv6 prefixes, subnet IDs, and the addresses in the subnets. All right. if the IPv4 subnetting concept are a little vague, you might want to go back and read the chapter. Yeah, okay. So we've gone over subnetting quite a bit here, guys, and we'll continue to go over subnetting because it is a big part, at least from my other colleagues that I've talked to. Obviously, they can't tell me the specifics of the exam, but they said at least for the most part that I need to have my subnetting up to par for the exam. So again, if you're going after your CCNA, make sure you got your subnetting down pretty well. Okay. All right. Deciding where IPv6 subnets are needed. First, IPv6 and IPv4 both use the same concept about where subnets is needed. One for each VLAN and one for each point-to-point WAN connection, serial or Ethernet. The figure shows an example of the idea using the small enterprise internetwork. Company one has two LANs with a point-to-point serial link connecting to the site. It also has an Ethernet WAN link connected to an ISP using the same logic you would for IPv4. Company one needs 4 IPv6 subnets. Okay, so it needs 4 IPv subnets. Okay, again, same process, same exact process that we would be using in correlation to when we're thinking about IPv4. Okay, all right. The mechanics of subnetting in IPv4 and IPv6, an IPv6 global unicast address. All right. To understand how subnets, to understand how to subnet your one large block of IPv6 addresses, you need to understand some of the theory and the mechanisms IPv6 uses. To learn those details, it can help you to compare IPv6 with some similar concept of IPv4. Okay. With IPv4, without subnetting, and an address has two parts, a network part and a host part. Okay. Class A, B, and C defines the length of the network part, with the host part making up the rest of the 32-bit address. Okay, so again, here is an example of IPv4. Okay, IPv4, class A, B, C. All right, when we had obviously our network portion here, and then the rest of our host portion, given this octet. Remember, octet is when we're talking about IPv4. Okay. So we have 2 octets here. We have 2 octets that govern a class B, and then we have 3 octets that cover the class C network, giving us the last octet for host. So this would be like the 192.168.1, and then obviously host bits from there we get subnetted out, and this would be 172.16. dot whatever, and this would be the almighty 10 network, where it's 10 dot pretty much whatever. Okay. All right. To subnet an IPv4 class ABC network, the network engineer for the enterprise makes some choices. Conceptually, the engineer creates a 3-part view of the addresses, adding a subnet field into the center while shortening the host field. Many people call this the borrowing host bits. All right. The subnet size network part stays locked per class ABC rules, with the line between the subnet and the host part being flexible based on the choices of the subnet in the figure show. So again, borrowing host bits. Okay, so that's one of the concepts behind subnetting in IPv4. Okay, where we have pretty much this would be a class A. This is stating it's a class B. So class B would be just an example. This would be the 172.16 network. All right, the 172.16, where this portion, these portion right here would be in the network. The 16, all right, the 16 bits, the 2 first octets, all right, that we cannot touch. So this is locked down. Okay, and then what we're doing is we're taking we're borrowing from the host to make other subnets. We're borrowing from the host bits, okay, to make subnets, okay, to make subnets. We're cutting up host to make subnets, okay, so similar concept, okay. All right. IPv6 uses a similar concept with the details in the figure. The structure shows three major parts, beginning with the global routing prefix, which is the initial value that must be the same in all IPv6 addresses inside of an enterprise. The addresses end with the interface ID, which acts like the IPv host field. So when we're thinking IPv6, we're thinking interface ID. So instead of thinking host bits for IPv4, instead we're thinking interface ID for IPv6. Okay, all right, same concept, different terminology. Okay, that's where some things can get confusing, especially with some of this networking stuff, where there's so many things. For some reason, there's so many things that are almost the same concept, but we're using different terminology, and that's where sometimes things can get confusing. Okay, the subnet field sits between the two other fields used as a way to number the identifying subnets, much like the subnet field in the IPv4 addresses. Okay, so again, same thing. All right, we're starting off with our global routing prefix. Okay, the global routing prefix. So again, to go back to the early example, the company's one global routing prefix was 2001, 0 Delta Bravo 8. All right, Delta Bravo. I forgot I caps lock still on 1111. Okay, so again, to go back to the example, the global routing prefix was this right here. Okay, and then obviously from there, we had all the rest of those other 5 quartets, okay, to subdivide. Okay, what we're doing again is we're borrowing from these interface IDs or host bits. Same concept, okay, just different terminology. All right, we're just borrowing from those to make subnets. Okay, to make subnets, same concept as we would be doing with IPv4, guys. Okay, all right. How's my coffee? My coffee's probably super cold now. It is, whatever. Still good. All right. Structure of an IPv6 global unicast address. Okay, we just kind of covered that. First, just think about the general idea with IPv6 comparing to the figure. The IPv6 global routing prefix, the prefix / length assigned by the RIR. I can't say that for some reason. There's too many R's, too many I's. Or the ISB acts like the IPv4 network part of the address structure. The IPv6 subnet part acts like the IPv4 subnet, and the right side of the IPv6, formerly called the interface ID, short for interface identifier, okay, acts like the IPv4 host field. Again, so same terminology, same concept. How's that? Let me take that back. Same concept of a host bits. We're just calling it interface, all right, or interface identifier, okay, all right. Now focus on the IPv6 global routing prefix and its prefix length. Unlike IPv4, IPv6 has no concept of address classes, so no present rules determine the prefix length of the global routing prefix. However, when companies apply to an ISB or RIR or any other organization that can assign global routing prefixes, that assignment includes both prefix and prefix length. After a company receives a global routing prefix, that prefix length, the length of the prefix, typically does not change over time and is basically locked. So again, that's stating a different rule that we must follow with IPv6. So it's a different rule we must follow with IPv6 all right, instead of having class A, B, C networks, all right, like we do still currently have in IPv4, we need to respect that IPv6 prefix length, okay? So our enterprise, our company that we're working for, what have you, registered for that assignment. They registered for that assigned prefix, all right? So we must respect that and keep that pretty much locked down, and then subnet from there. So honestly, I mean, there should be no reasoning to touch those prefixes anyways, just because how many other addresses you have and how much you can actually subnet a IPv6 network. I mean, it's enormous. It's enormous. Okay. All right. Next, look at the right side of the field, the interface ID field. For several reasons, that becomes more obvious the more you learn about IPv6. The field is often 64 bits long. Again, 64 bits long. Okay, huge. Does it have to be 64 bits long? No. However, using a 64-bit interface ID works well in real networks. There are no reasons to avoid using a 64-bit interface ID. Finally, look at the subnet field in the center. Similar to IPv4, the field creates a place with which to number IPv6 subnets. The length of the subnet field is based on the other two factors: the length of the global routing prefix and the length of the interface and ID. And with the commonly used 64 prefix interface, the 64-bit interface ID field. The subnet field is typically 64 minus P bits, with P being the length of the global routing prefix. Okay. Now, next, excuse me. Next, consider the structure of the specific global unicast IPv6 address. Okay. All right. Let's take a look at this, guys. All right. Remember, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 quadtets. All right. They all equal 16. Okay. All right. So they all equal 16. All right, which gives us 128 bits. Forgot I still got my caps lock on. All right, equaling 128 bits. All right. Now, when we go into here, all right, we have our prefix length. All right, we have our prefix length at 48. Okay. All right. What we do to subnet divide, we take the next one. All right. Let me make that a different color, actually. We take the next quadtet. All right. Now we just created the /64. Okay. 48 plus 16, 64. Right? Right? Is that 56? My math is outrageously awful sometimes, guys. Yeah, 64. Awful my math is. Simple arithmetic gets me every time. All right. Again, giving us the last 64. All right, 16, 16, 16. Last 64 interface IDs. So interface IDs here to play around. So again, this address here now. All right. So now we have a address of 2001. All right. We're going to remove that. We can remove that 0 from the leading. Remember, we can remove leading zeros. Okay. Delta Bravo 8. All right. Colon 1111. Colon. Again, we can remove leading zeros. 1. All right. And how many do we have? We can remove all those. So colon. All right. 1. All right. Actually, we can't remove that one. Can I remove all those zeros though? Or do I get in trouble? Oh no, I can't. So it'd be 0, 0, right? 1, 2, 3, 0, 1 / 64 now. All right, so that would be our address now. Boom, wham bam, thank you, ma'am. We just assigned our first address in our enterprise. Okay, so we have the 2001 Delta Bravo 8 1111 :1 :0 :0 :0. I messed this up because I need : /64 to make this correct. All right, :1 :64. All right. So there's our first address. Okay, and the reason why I could not remove, and this is what I learned yesterday, not yesterday, the day before yesterday, when we started getting into IPv6, is because we can only do the : once inside of the address field. What I thought I could do, I thought I could remove all the zeros by giving the : again, and then giving the : at the end with the /subnet mask, subnet ID, whatever. No, the prefix. So the prefix line. This is not IPv4. Again, same concepts, different terminologies. All right. And this would be a correct address now. Okay. All right. Let's move on. All right. Again, pretty much what we just talked about. This right here, the 01 would be the first subnet inside of our global prefix length. Okay, so our global prefix length, okay, 48. All right, we're gonna carve out 16 bits. All right, we're gonna give it the 0001, giving us our first subnet, our first prefix subnet. Yeah, so subnet ID or prefix ID, and then obviously our host. All right, which would be the 1. All right. The company Yep. Okay. All right, we're looking pretty good. How's everybody doing? Hope everybody's doing good out there. All right. The example in the figure, all with a little math, shows one reason why so many companies use the /64 prefix length for all subnets. With this structure, company 1 can support 2 to the 16th. So 2 to the 16th. So 2 to the 16th, guys, gives us an exorbitant number. Okay, 65,536. 65,536. All right. Yeah, we can make a couple subnets. All right, we can make a couple subnets. We have the ability, guys. We have the technology. It's real. All right. And there it says 65,536. Few companies need that many subnets. All right. Then each subnet supports over 10 to the 18th addresses. All right. Let's break our brains for a second here. All right. I'm gonna break my brain. 10 to the 18th. All right. So there you go. All right. How we doing? 10 to the 18th. What is even that number? What is that number? I don't even know. Is that a Google? That might be a Google, actually. Let me see. 100 million, billion, trillion, quadrillion. What's after a quadrillion? What's after a quadrillion? I don't even know. It might be a Google. I don't know. It's a big number. What's his name? The owner of Amazon doesn't even have this much money. All right. Listed in the IPv6 subnet identifier, 1016. All right. So for both subnet and host, 10 to the 64th minus reserve fields. So for both subnet, host, and IDS, support far more than needed, plus the /64 length for all subnets makes the math simpler because it cuts the 128 IPv6 in half, field in half. listing the IPv6 subnet identifier. Like IPv4, the IPv6 needs to identify each IPv6 subnet with some kind of subnet identifier or subnet ID. List the informal names for this number subnet ID and more formal names prefix ID. So the informal name, okay, again, the informal name subnet ID, or the formal name the prefix ID. Okay, same concept, just different terms. Same concept, different terms. That keeps coming up, and that will continue to come up in networking. All right, because you got to think, networking in general. All right, it was an idea that was spread across the world. Okay, it was an idea and concepts that were spread across the world, and many intelligent and awesome people across the world. And I'm not saying, I mean, this was everybody. This was a huge planetary, global concepts and ideas that everybody helped work. They worked really hard to make this happen. But again, what happened is everybody had their own terminology for what they called things, this and that, and the other thing. Obviously, over time, we've tried to make the terminologies come back to almost being the same thing. But again, there are so many different terminologies, but they all sometimes have the same concepts. We're just using different terms to label certain things, okay? So that's one thing that gets confusing when we're getting into networking, okay? All right. Chapter 22 in the yada also discussed how to find the subnet ID given IPv6 addresses and prefix length. The math works the same way when working with global unicast addresses, as well as the unique local addresses discussed later on the chapter. Chapter 28, securing the wireless network, has already discussed the math, but for completeness, note that the subnet ID shown here. Okay. Oh, so this is just showing us the subnet ID. All right. This isn't showing the host portion, the interface identifier, the interface number identifier. Okay, so it's just showing global prefix and then subnet. Okay, so global prefix again, global prefix. All right, and then prefix or subnet ID. Okay, equal 1, and then giving us the complete prefix of 64. Okay, all right. It's not showing the host bits in this ID, in this address range right here. Okay, guys. All right. List all IPv6 subnets with IPv4 if you choose. If you choose to use a single subnet ID mask for all subnets, you can sit down and write down. You can sit and write down all the subnets in class of a class ABC network using that one subnet mask. With IPv6, the same ideas apply. If you plan to use a single IPv6 prefix length for all subnets, you could start with the global routing prefix and write down all the IPv6 subnet IDs as well. To find the subnet ID, you simply need to find all the unique values that will fit inside of the subnet part of the IPv6 address. Basically follow these rules, okay? All subnet IDs begin with the global routing prefix. Again, you cannot, that's given us, again, it's different. This time that's different. So the class A, B, and C to the prefix, the global routing prefix is different. That's a different concept, similar in some fashion, but slightly different. Okay, so that is what our enterprise, our company has given us. All right, has registered for and given us. We cannot touch that global routing prefix. Okay, That's permanent. That's will always be in our address ranges. Okay, we cannot touch that. Okay. All right. And that's why it's stating all subnet IDs begin with the global routing prefix. Okay. All right. Use a different value in the subnet field to identify each different subnet. Okay. Simple enough. All subnet IDs have all zeros in the interface IDs. Cool. So again, just like we when we do IPv4 subnetting, all the host bits have all zeros in it when we're trying to find that subnet ID. Okay. All right. Similar concept over here in IPv6. Instead of calling it host portion or host bits, whatever have you, we're calling it interface ID. Okay. All right. All right. As an example, take the IPv6 design shown in the figure, and think about all the subnet IDs. First, all subnets will use the commonly used /64 prefix length. This company uses the global routing prefix of 2001 0 Delta Bravo 8 11111::/48. That's our global routing prefix. Okay, global routing prefix, which defines the first 12 hex digits of all the subnet IDs. To find all possible IPv6 subnet IDs, think of all the combinations of unique values in the fourth quartet. Quartet, there's that word again, quartet. Instead of octet, we're thinking quartet. Okay, all right. And then represent the last four quartets with all zeros with the : symbol, all right, and if shown in the figure, the beginning of just such a list. All right, cool. So here we go. Very, 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 very nice, very easy. All right. Again, remember when we went slightly over hexadecimal, so that it obviously A, B, C, D, E, and F. Okay, that's just hexadecimal. A represents 10, B represents 11. C represents 12, D represents 13, E represents 14, and then F represents 15. Okay, I know hex might be new to some of you guys out there, and it might be somewhat confusing. But A, B, C, D, and F are actual hexadecimal numbers. Okay, all right, with representing those values. Okay. So here would be our first subnets that we got to play with. Okay, obviously the zero subnet that would just be that whole entire range right there. But we'll start at 1, obviously. So we'll start at 1, and we can go all the way down to 15, which is representing by that F there. Okay, so that would be our first subnets that we got to play with. Okay. All right. Very good. Well, at least our first 15 subnets that we get to play with. Okay. All right. So yeah, first 16. Yeah. Possible subnets with the 16-bit subnet field in this example. The example allows for 65,536 subnets. So clearly, the example will not list all the possible subnets. However, in the fourth quartet, all combinations of hex values would be allowed. Okay. The IPv6 subnet ID, more formally called the subnet router, and any cast address. So any cast address is reserved and should not be used as a IPv6 address for any host. All right. Assigning subnets to the internetwork topology. After the engineer lists all possible subnet IDs based on the subnet design, the next step is to choose which subnet ID to use for each link that needs an IPv6 subnet. Just like an IPv4, each VLAN, each serial link, each Ethernet wide area network link, and many other data link interfaces need a IPv6 subnet. Okay, so again, when we're splitting things off between router to router, we need different subnets. Okay, when we're creating VLANs, we need subnets. Okay, that goes back to that question I was asked earlier. Why would you subnet an IPv6 address? Because it's fundamentally, you still have to think about this the same way you would think about IPv4. Okay, it's fundamentally it's the same thing. It's just obviously we have more addresses now. Okay, but IPv6 gives us the very simple way of doing this. It's given us the /64, and we don't have to get any more complicated than that. All right, when we're doing this, okay. So yes, we still have to subnet it, but IPv6 gives us, okay, well, you just have to use the /64, and you got 65,536 addresses, subnets to create and have fun with. Have fun, and that's all we have to do. That's it. Too easy. All right. All right. Let's move it. Let's keep it moving. Let's keep it moving. All right. Subnets in company one with the global routing prefix, yada yada yada. /48. So again, it's just here we go. Again, very easy concept, guys. We're just again, here's first subnet, second subnet, third subnet, okay, fourth subnet, okay. All right, between the links, gig 01, gig 00, and then gig 000 to gig 010, and then off of this router 2's gig 00 interface, and then between router 1 and ISP over here off of gig 010 and off of gig 00 we have obviously this address too, guys. So okay, similar concept, guys. Similar concept. Okay. Whoa! I just put a dot there. Boop. Very good. All right. Now the engineer has planned which IPv6 subnet will be used in each location, and the additional IPv6 subnet addresses can be planned and implemented. Each address must be unique in that no other host interfaces use the same IPv6 address. Also, the host cannot use the subnet ID itself. The process of assigning IPv6 addresses to interface works similar to IPv4. Addresses can be configured statically along with the prefix length, default router and domain name system (DNS) domain name system. IPv6 addresses. Alternatively, hosts can learn these same settings dynamically using either dynamic host configuration protocol (DHCP). I always love me some DHCP. Or the built-in IPv6 mechanism called stateless address auto configuration. So give me some slack. All right. For example, in the figure, shows some static IP addresses that can be chosen for the router's interfaces based on the subnets shown in the figure. In each case, the router interface uses an interface ID that is relatively low, easy to remember. Relatively low and easy to remember. All right. Again, here we go again. Very easy. Very easy. And we're gonna go. We'll go over to we're gonna go lab this up too, guys. Okay. All right. Whoa. That's too big, man. That's too big. You can't see nothing like that. All right. Subnet ID. So prefix ID or subnet ID, obviously. All right. And then we come over here, and then we have interface ID, interface ID, and then so on and so forth. Okay. So again, we're just assigning addressing to our topology here, guys. Okay, similar to what we would do in IPv4. Okay. But obviously, IPv6 gives us a larger subnet field, so we just have to use that /64, guys. It's very easy. Let's make it happen, Captain. Let's make it happen. All right. This chapter puts up details of how to configure an IPv6 addresses to chapter 24. So once we get over to chapter 24, that's when they get into the discussion of implementing IPv6 on a router. IPv6 on a router. Okay. All right. Now, let's finish off this chapter by talking about unique local unicast addresses. Okay, unique local unicast addresses act as private Okay, private IPv4 addresses. These addresses have many similarities with global unicast addresses, particularly how to subnet. The biggest difference lies in the literal number. Unique local addresses begin with the hex FD. Okay, so 1513, right? 1513, right. Yep. And with the administrative process, the unique local prefix are not registered with any number authority and can be used in multiple organizations. Exactly, just if we were to, when we're doing classless interdomain routing, okay, and when we're using NAT and PAT inside of our home or inside of our enterprise, right? When we're using private IPv4 addressing, I could have the address 192.168.1.1 at my house, and you can have that same exact address at your house, the 192.168.1.1 at your house too. All right, but we can both get out to the internet. But when I send a packet out to the internet, you're not going to get my packet, and I'm not going to get your packet. Okay, that's because our home routers are doing that and PAT and stuff like that. Securing, making sure that the information that we're routing out gets routed back to us after that. Okay. All right. Although the network engineer creates unicast addresses without a register or assignment process, the addresses still need to follow some rules. Okay, so we need to still follow some rules. Okay, use FD as the first 2 hex digits. Choose a unique 40-bit global ID. Append the global ID to FD to create the 48-bit prefix. Use as the prefix for all your addresses. Use the next 16 bits as the subnet field. Note that the structure leaves the convenient, again, 64-bit interface ID field. Okay, so it's still leaving us with the 64-bit ID field. Okay, there's the figure. Just to be completely exact, the IANA actually reserves prefix FC00::/7 and not FD00::/8. For these addresses, FC::/7 includes all addresses that begin with the hex FC and FD. However, an RFC 4193 requires the 8th bit of these addresses to be set to 1, which means that in practice today, the unique local addresses all begin with their first 2 digits as FD. Okay, cool. All right, let's continue on here. All right, subnetting using unique local addresses works just like subnetting with global unicast addresses with a 48-bit global routing prefix. The only difference is that the global unicast, you start by asking for a global routing prefix to be assigned to your company, and that global routing prefix might or might not be a 48 or may not have a 48-bit prefix length with a unique local. You create the prefix locally. Let me say that again. With unique local, you create the prefix locally. All right, and the prefix begins with /48, with the first 8 bits set in the next 40 bits are randomly chosen. Okay, so remember, so we keep the FD when we're doing unique local. We're keeping the FD in the first 8 bits. So the FD has to be in the first 8 bits. Okay. All right. And then from there, then we create the other 40 bits. So we randomly create the next 40 bits. All right. and then we obviously then we subdivide the 16 and then keep the last 64 bits for interface IDs here. Okay. Locally begins with the 48. Yep. All right. The process can be simply as choosing a 40-bit value as your global ID. These 40 bits require 10 hex digits, so you can even avoid thinking in binary, all right? And just make up a unique 10 hex digit value and add hex D to the front. For example, imagine you choose 10 hex digits value of hex 00000010001. Pretend a hex FD making the entire prefix be FD00 colon 0001 colon 0001 colon slash 48. Boom. Now I have my unique local address. All right. Then I use the next 16 bits. All right, the next 16 bits as my subnet field. All right, so giving me then the FD0000010001 colon 0001. All right, colon slash 64, and then I have all those bits there for host. Okay, and then I can continue to make more subnets from there. Okay. All right. To create subnets, just as you did in the other example with the 48-bit global routing prefix, treat the entire fourth quartet as a subnet field. Shown in the example subnetting plan using unique local addresses, the example repeats the same topology shown earlier. That figure showed subnetting with the global unicast prefix. This example uses the exact same numbers for the four quartet in the subnet field, simply replacing the 48-bit global unicast prefix with the now new local unique prefix. Okay, so the FD00 colon 0 colon 1 1. Okay. Very good. All right. Again, same as that concept, guys. Same as that concept. We're just using, again, we're using that 16-bit fields for our subnet IDs here. Okay. All right. So again, we have our unique local. We have our unique local address. Okay. Given the FD that mandates it to be there for the unique local. All right. And then we just assign the 40 bits. Okay. These were the 40 bits that we assigned randomly, or keep it simple. All right. And then obviously now we have our 16 bits. All right. That we're using for subnet IDs. Okay. All right. Again, giving us the /64. All right. The need for globally unique local addresses. The example in the figure shows an easy to remember prefix, FD00 colon 1 colon 1 colon 48. Clearly, I made up the easy to remember global ID in this example with the global ID. What global ID would you choose for your company? Would you pick a number that you could not abbreviate or make it shorter? If you had to pick the IPv6 prefix for the unique local address for the options in the following list, which one would you pick for your company? Okay, so again, which one would you pick for your company? Would you pick a complicated one? You know what I'm saying? A couple complicated ones, or would you make a nice easy peasy, a squeezy one? Okay, I think I like the lemon a squeezy one, huh? All right. Everybody likes to squeeze lemons, huh? Just don't squeeze them in your face. Ah, my eyeball. No. All right. Given freedom to choose, most people would pick an easy to remember short to type prefix. Let the FD Fox Delta 00:1:1:/48, and in a lab and in other small networks used for testing, making up easy to remember number is reasonable. However, for uses in real corporate networks, you should choose not to make up the global ID you should try to follow the unique local address rules that strive to help make addresses unique in the universes, even without registering for the prefix with the ISB or the IRR. Okay. All right. RFC 4193 defines unique local addresses. And that RFC stresses the importance of choosing your global ID in a way to make it statically unlike to be used by other companies. What is the result of a global ID at IDs at every company, making all unique local addresses unique across the globe. So if you do plan to using a unique local addresses in the rail network, plan on using a random number generated logic list in the RFC 4193 to create your prefix. Okay, plan on using the random number generator logic listed. Okay. All right. One big reason to attempt to use the unique prefix rather than everyone using the same easy remember prefix is to be readable for the day that your company merges with or buys in another company. Today, IPv4 is a highly today with IPv4 a high percentage of companies use private IPv4 networks, the almighty 10 network. All right. When they merge their networks, the fact that both use the almighty 10 network makes the network merge more painful than if companies use different private IPv networks. Excuse me. With all IPv6 unique local addresses, if both companies did the right thing and randomly choose a prefix, they would most likely be using completely different prefixes, making the merge much simpler. However, the companies that take the similar easy way out and choose an easy to remember prefix like the FT00:1:1 greatly increases their risk of requiring extra effort when merging with other companies. That also chooses to use that same prefix. Okay. Again, it's just saying like if I was to buy company A, and company A was using the almighty 10 dot whatever range, just because they were using the 10 network, and company 2 was using the almighty 10 network, what would happen is their private, okay, remember private, not public, their private internet addresses would most likely overlap into company A. All right, so if they were to merge, those addresses would overlap each other. Some devices would have the same addresses and stuff like that, and it would just be a slosh posh of things to figure out. Okay, and what's this pretty much stating with IPv6? As long as we're using the random generator, okay, if we're using some kind of random generator to create this prefix length, that most likely when we merge with company A or B, that our addresses should be different. Okay, we should have different prefixes. Okay, all right. All right. What's a do a lab? All right. Remember, guys, if you guys are up on how does that work? Hold on. I just got to log into my server real quick, guys. I got timed out of my server. That's no big deal, man. Oops, I don't want to keep my caps up on anymore. Come on, baby. Come back to me, baby. Baby, come back. There we go. Alright, you know what I gotta fix this because I was gonna update this the other day. I just want to do it real quick. This is part 7, not part 6. How'd that sit down, man? Alright, so we're over here in Cisco Modeling Lab. I just had to log back into my server real quick, guys. Alright, so if you guys, again, if you guys are up on, you guys don't even need Git, obviously. But if you guys, if you guys want to jump on, my Discord, what I've been doing is on Git, and again, you don't need Git, but what I've done is when I create labs now in Cisco Modeling Lab, I created a channel on my Discord, all right, here, that you'll be able to just click on this link here, and you can do it on your phone or whatever, all right, and you'll be able to actually see the configuration, all right, in the YAML file, okay? So, and the reason why I wanted to do it via Git and not just upload YAML files to Discord is I didn't want people just downloading YAML files. You can go on my GitHub and download the YAML file. That's not what I'm saying. Is not everybody would want to download a YAML file. You know what I'm saying? Not too many people even know what a YAML file is. All right, let alone downloading one and having a hard time opening one to take a look at it. So that's why I made this a corporation with Git, with Discord and Cisco Modeling Lab and this stream here, okay? So when I upload something to my Git repository here, so I'm gonna, after we're done with this quick lab, and this is just gonna be a quick lab, you'll see what I'm gonna do. I'm just gonna drop it into my Git repo here. All right, this is just my Cisco Modeling Lab repo here, and I'm gonna load it up via the web GUI because I don't want to do it through the command line, just because I got this thing so locked down that it requires all kinds of tokens and stuff like that, and I don't want to expose all my tokens via live stream. That wouldn't be cool. So I'm just gonna bloop, drop it right in there after we're done. Real easy peasy, a lemon and a squeezy. All right. Let's grab some routers here. We'll grab one router, a 2 router. Give me a 3 router. All right. Bloop, bloop. All right. Let's get these batteries names real quick, eh? And let's turn them on. Let's get it on. So I have used, I'm like super familiar with like IPv4. This would be the actual first time I've this would be the first time like I've done any assigning IPv6 addresses and stuff like that. So tomorrow chapter 24 is all about implementing IPv6 on a router. So we're kind of touching on that. We're kind of gonna touch on that tonight. Well, right now, and I may touch on OSPF version Trace Amigos to implement OSPF IPv6 OSPF on this lab. Yeah. Yeah. I think that's what we're going to do. Yeah. Though I'm not too familiar how to per se do it. But we're gonna do it somehow. Good evening, you wonderful positive attitude. IT geek you. Good evening. Thank you very much, man. I appreciate that. How are you, gaming golfer? How are you today, my friend? Good to see you. Welcome back to the stream, man. Alright, we're going over some IPv6. Woo! Those routers came up. Alright, let's tell these. Let's raise this up so this doesn't break. And we can get rid of that. Just relaxing after a long ass day. Ooh, I feel you, my friend. I feel you. I feel you. I'm glad you're relaxing. I really am, my friend. I'll tell you, there's nothing like chilling out and relaxing. And thank you for coming in on your relaxing time. I appreciate that. That actually makes me feel good, man. That you want to hang out with me. So thank you, man. Glad you had a good day. I myself, I got some good news. I hopefully will be getting another new job. All right, because the new job that I'm doing now, I'm getting so tired of. So I've been applying to other places, and I got some. I got all my pre-employment stuff, for the most part, done. I just have to go in tomorrow to do some lab test. Just have to go for urinalysis and whatnot. Because I'm going to be hopefully operating a forklift again. Because honestly, I can't do the job that I'm doing now is a retail. No, it's not, dude. I've been applying to IT places like crazy. Like every IT place I've been applying to, they all come back telling me that I don't have. First of all, I don't have any. They keep telling me that either I don't have enough experience, or I'm not. They're not interested. I'm not a candidate that they're interested in, which is completely a bummer, dude. Because and I'm not applying to network engineer jobs. I'm applying to like very junior stuff. Obviously I should be applying to like help desk positions. To just get my foot in the door. But it's, I don't know. Like, I'm not trying to down on anything help desk wise. It's something I should do, just to get my foot into the door of some kind of IT type stuff. But I tell you, like, even junior stuff. I mean, they're not even looking at me, and I'm yeah. Exactly. Exactly. And it's like, what I've been trying to do, and like what I've been trying to do on my resumes and stuff like that, is show, I put in my resumes my YouTube and my Twitch stuff. Okay, hopefully, I'm just at the hopeful chance that who is ever looking at my resume is somewhat is a person of our age group that would say, okay, are they they possibly doing something on Twitch and YouTube that is related to networking? And that's what I've been trying to gear towards on my resumes. Okay, if you don't think I have enough experience, well, look at my YouTube and look at my Twitch stuff and see what I'm doing on Cisco Modeling Lab, see what I'm doing on these streams, so you can kind of guess or trying to get the sense that at least, yes, I might not have the quote unquote qualifying years of experience, but at least I have the fundamental knowledge and I'm chasing after the fundamental, these certifications, whatnot, to at least try to get my foot in the door, I would think with my managerial experience, my military experience, and all these other experiences that I've had, that someone would have said, hey, at least let's give this guy a shot. But nope. So, the job I'm doing now is it's an overnight retail cashier job, and I hate it. I've been fighting with people like crazy. So many people, I got so many people that come in that don't believe in wearing their mask and stuff like that, or they're coughing and sneezing and stuff like that all over my face, and I just want to punch them all in their teeth. And I got yeah, whatever. If you've worked retail, you know how it is. And so I've been applying to all these other places, and I finally landed a gig at a freight, at a shipping freighting company. And the good thing about that is it'll be, because I'm working like 50, 60 hours a week at this overnight cashier, and I wasn't even intending to work that many hours, just because of I'm doing school, I'm doing this, and I'm babysitting my kids during the day while my wife works during the day. Like, working that many hours is stressing me out. As much as I need the money right now, that's just way too much for me to handle. So this freight gig should be about half that. Should only be about, which stinks, because it's gonna be a cut in the money, but it's even more money per hour, but it's still not gonna equal out either way. But I don't really care at this point. I just want to get out of that stinking overnight. Well, this is gonna be overnight either way, but at least it's not gonna be that many hours, and I'm not gonna have to deal with crazy customers pissing me off in the middle of the night. And I'll be operating a forklift again. Yeah, hopefully, once we get this CCNA cert done, and I can get this on my resume, hopefully, I will at least be, looked at for a junior position. You know what I'm saying? Hopefully. Praying for this, man. I just want to get, because this is what I want to do this. You know what I'm saying? This is what it's all about. This is what I'm going to college for right now. So, all right, enough of that. Did you really? Yeah, I'm a heavy equipment operator by trade. I've run, D7 dozers and huge front end loaders. I've run all kinds of stuff. Wheeled and tracked excavators, backhoes. That's what my background is in heavy equipment operations and road construction and landscape construction and stuff like that. And then obviously I think I've talked to you already about how I hurt my back and whatnot, and it kind of put an end to me jumping in and out of equipment anymore, because of I need my hip replaced now, and I'm gonna need back surgery and whatnot. And I was paralyzed for a little bit, so that's obviously why I'm going, changing the careers up, so I can at least keep my body going for a couple more years before I fall completely apart. Huh. I mean, it's all. I mean, if you ran a forklift, it's all. After that, it's it's things get bigger, but it's almost the same concept. I mean, it just gets you know things just get more powerful. You can just how's this? You can just break more things the heavier equipment is. The bigger, the heavier you are, the more things you can break. Pretty much. That's about it. All right, let's do this. All right. Now let's do this. Ba ba boom ba boom ba boom ba boom ba boom. All right. IPv6. IPv6. Unicast routing. All right. So we've just implemented IPv6. Okay. Now let's hook up some interfaces. Let's say gig 1, then gig to gig 1. So interface gig /0. All right, IPv6. All right. Now we're gonna go with the example with the FD. All right, FD00. That's the one, right? Yep. Yep. We're gonna use the same exact concept, okay, guys? Just to keep things simple for now. One, and then pretty much this is giving us the FD as our first quick, super easy pop quiz. What are the 3 IPv subnet ranges that are reserved for private networks? So we have the Class A, the almighty Class 10, Class A, and then we have the Class B, the 172.16, all the way to the 172.31. 2 for 5, and then we have the almighty one, the Class C, the 192.168 a dot 00 to the 192.168 to the 2 for 5. Thank you, Gamer Golf. That was a good, quick question. Quick pop quiz question. I like that. The pop quiz questions. So we have, and then what's kind of right? We'll write this out too, guys. 1, and then all right. So then 0001. All right. So this is our first 1, 2, 3. So our first 48. So this is our first 48 bits right here. All right. So this will be our unique local address right here. So the FD0 0001 colon 0001. All right, and then we're gonna give this the subnet ID of 0001. Okay, colon, and then 000 0 1 2 3 4 5 0 0 0 0. Okay. So got 1, 2, 3, 4, 5, 6, 7. Okay. Whoa. Salud. Seven. Yeah. All right. Like I said, this is the first time I've done. This is the first time I've messed really with. This is the first time I've ever assigned. So that right there, guys, first time I've ever assigned an interface with a IPv6 address. Woo 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 woo. All right. So we got that one now. All right. Now I wanted to do. So let's do this now. Exit. Let's go into router, OSPF. I want subnet areas. Yeah, process ID 1. Let's give this the router ID. Yeah, okay. 1.1.1.1. Now, one thing I haven't learned yet is how the OSPF version 3 works on IPv6 and how that addressing kind of works. You know, we'll do this actually on the interface to keep it simple. So let's exit out of here. Let's go back in interface gig 0-0. And let's do this. Let's do IPv6 router OSPF. Hmm. Oh, so we need to do a router ID in this area too, huh? So router ID 1.1.1 area 1 range, and that's the F, FD00 colon 1 colon 1 colon 1. Yeah. Yep. /48. All right, that should have done it now. Now we're gonna have to just implement that. So what made you focus on Cisco network opposed to other IT fields like servers? Um, so great question, Gabriel. So what made me solely focus on Cisco first is because of what the CCNA exam covers. So it wasn't so much of Cisco, but what the CCNA exam itself covers, the broad scope of how much information you need to learn just to pass the CCNA exam. All right. Now, from there, obviously, then I've talked about I'm going after my DevNet associate exam. So if I don't know if you know anything about the DevNet exam or heard of the DevNet exam, then we get into Python. We're gonna get into Linux operating systems. We're gonna be using Bash. All right. And then we're gonna be doing a lot in Ansible. Okay. Virtualization. So to kind of give you a scope of what else I do, what else I've been learning and stuff like that. I know I really haven't streamed a lot about it, but I on the side, because I'm trying to get ready for my DevNet exam, um, what I kind of started off with doing a lot of virtualization stuff, and creating servers. So this is obviously EXXI. You might be familiar with EXXI or Proxmox or something similar. I got in the actual server itself, I got a little NX group right here. This is a virtual switch. So if you're familiar with virtualization, platforms that you can create your own virtual switches on, I created a virtual switch. I just named it the NX group, whatever. I just gave it a random name, and I assigned these VMs to it. Now there's one VM, this NX router VM. This is a pfSense. So this is a pfSense image. All right. You might be familiar with pfSense. So pfSense is it's a virtual routing image. Obviously, this is built on top of a Ubuntu Linux OS, but it's a virtual router. All right. And what I did inside of that NX group, I have my virtual router here performing NAT and PAT for these other images here. So the reason why I have an Ubuntu desktop in this router is so I can access the web GUI for the pfSense router here. So then I can obviously do configurations through the web GUI. And the reason why I needed to do this all and to do it to break it off was because I was building DHCP servers. I was in the process of building a DNS server as well, but I needed to take that off of my actual house, my home network, because I didn't want. The last thing I wanted was another DHCP server and a DNS server trying to allocate things in my house, addresses and using DNS and stuff like that. But what I was doing was I was adding, I have a Fedora server in here and I have an Ubuntu server in here, and I was just going through the month, even though Fedora and Ubuntu are both Linux, the primarily fundamentally, almost the same, but they're different as well. They're very different. Commands somewhat different. Files structure and stuff like that is a little bit different. So I'm not just generally focusing on Cisco. It's the fact of what the CCNA exam covered, and I feel as though the CCNA exam is such fundamentally it's such a great exam because of what you're going to learn from it. You're going to learn everything you're going to need to know. At least this is just my opinion. I mean, anybody is more than welcome to argue with me, but I'll argue back that fundamentally everything that you're going to learn going after the CCNA exam is super important for anything, in my opinion, IT. At least from my knowledge right now. So that's my little synopsis on that. So, cool, great question, man. I appreciate that, Gamer Golfer. So, which area are you most excited to dive into after CCNA? So that'd be DevNet. So I want to get into to automation. My whole where I want to continue to dive into. It's not security, anything like that. It's automation, in programmability and stuff like that. That's where I want to. That's where at least I see my education and where I want to take my career wise is in the automation and programmability and cloud and cloud architecture and stuff like that. Cloud architecture, virtualization architecture, and stuff like that. Like that's the reason why I went back to school to get my bachelor's degree. Because of when I started applying for places like Amazon, AWS. Oh, well, thank you. Yeah, so the reason why I went back to college was obviously to get my bachelor's degree. So I want to, after I get my bachelor's degree, I'm going to start applying for at places like AWS, Azure, and stuff like that. And one of the sole requirements is you need a bachelor's degree. So on top of everything that I'm going after now, I'm kind of layering my cake with all these certifications and that bachelor's degree. I'm also going to be squeezing in this, like, following the CCNA certification and the DevNet and stuff like that. We'll be getting to the AWS practitioner certification. We'll be going after the Azure certification. We'll also, the other big one that's going to take me a little while too is I also want to go after the Red Hat certified Linux certification as well, and that's another big horse to tackle too. But it's one that's going to be worth me really diving into, is all things Linux, because obviously, as you probably already aware of, Linux is what's running the internet right now. You know what I'm saying? Yes, I know, Windows, Microsoft with Azure, there are things running, Windows servers and stuff like that. But for the most part, for the most part, Linux, Red Hat Linux is pretty much running the internet. All right. And that's going to be going after my Red Hat certified Linux certification is going to be, is it really? I wasn't aware of that. Well, that's one thing we're gonna have to track. It's funny that you just brought up IBM, because the company, the cashier company that I'm working for, they use a thing called Z operating system, and I never heard of Z operating system, and I looked it up because it's complete trash. At least in my opinion, it's complete trash, and it's an IBM. It's an IBM. It's an IBM operating system that they use at their databases, at like their big server farms there, and I hate it. Because once I saw what it was, it's like I went to look. I'm like, what the freak is this operating system? Because it wasn't something I had seen before, at least in my experience. So it's funny that you just brought up IBM, because I hope I'm just if IBM just acquired Red Hat, I hope they don't start messing with it. if they do, everybody else will probably move on to something. You know, they'll just go back to Ubuntu then. But yeah, thank you for telling me that. Honestly, that's I. You know, it's I gotta add more things to my. I got a whole bunch of things that I follow on Reddit and stuff like that. I should have probably added the Red Hat certified the Red Hat uh, uh, Reddit thing to my Discord. There's your automation career right there. You can help automate all the TV stuff on this. Dude, it's trash. It's complete trash. It's trash. I wanted to smash their computer. That's how trash it was. What is this booty crap? Get this booty crap off of this thing. Let's move into the router 2 here, guys. All right. EN. T. All right. Let's do the same thing. All right. IPv6. Unique. There you go. Unicast routing. All right. Interface. Gig 01. 6. Address. FD. 00. 1. 1. 1 is our field, and then 2. And then 1, right? 0, 0, 1, 2, 3, 4, 5, 6, 7, / 64. Okay. All right. Now exit, and then we have to do IPv6 router OSPF 1 E 2.2.2.2 area 1 range FD 00 colon 1 colon. Let's see if we make a neighborship. I've never used OSPF version 3 yet. I may have not done this correctly. That's it. All right, let's do a ping. FD 00 1 1 7. To show IPv6 So I did not do the IPv6 route Well, I didn't implement. How is this? I didn't implement OSPF right. Because it's not on the actual interface, right? Let's do this then. Yeah. Interface gig 00. B6 OSPF 1 0. Neighbor. Link local address. Use. That's command. Oh, am I falling into the NFL playoffs right now? So, honestly, like this, I don't know what happened this year with me and following the NFL. Like, I haven't been able to pay attention, um, to the NFL. I know that, I know Brady, Brady's actually, what is he's going, he's up going into the uh, finals there, uh, going against It's Green Bay right now. Um, so that ought to be interesting to see. It's weird seeing Brady because obviously I'm out here. I'm out here on the East Coast. Originally from Massachusetts. So I've been a Patriots fan forever. So it's strange seeing Brady in a different uniform. But that's cool. Whatever. You know what I'm saying? The dude's doing his thing. Um, but good on him. You know what I'm saying? It sucks that the Patriots didn't make it this year, but what that's fine. Their team's not what it used to be. Uh, but yeah, so and then what's his name ended up getting concussed pretty bad on the last game. But yeah, I really haven't followed the NFL too closely. Again, this year's been a weird year for me. Um, but it should be either way. It should be an interesting to see what happens with these playoff games, and then obviously leading up to the Super Bowl here shortly. Um, so yeah, and it's supposed to be. Oh, have you been a? Oh no, snap! Yeah, so this is awesome for you. So you must be pumped up right now. Are you happy to see the Mr. Brady on the team now? Mr. Thomas the Brady. He's a good quarterback, man. The dude's got skills. Everybody hated on him for a while, but he's got skills, man. So neighbor link local 6 address. Right? No, I'm saying he's a badass. He's always been an amazing quarterback. You know what I'm saying? And you know, he's a leader. You know what I'm saying? So he must have rallied up the troops around him and got the team to do what they needed to do, and they had a awesome year this year. So kudos on all the the Buccaneers teams out there. They worked hard to get where they're at. Again, it's been a strange year for football, nonetheless. But yeah, it's been an interesting year. It's random distractions like this happen all the freaking time while you're working in that was a good one. I like that. It's a 1-1. Call in. Needs to be a link localized. Man, OSPF version 3 is kicking my butt right now. We may not be using. All right, let's do this statically then. It is kicking in my butt there. We're gonna have to spend some more time on basically um well the CCNA exam. I don't think the CCNA exam covers OSPF version 3 though. Um, B00. Let's go over here.
Just looking for the FD 00 101 2 slash 8. IPv6 is kicking my butt. There we go. We're in static IPv6 service. That's fine. All right. Do it real quick, real easy, like that. There we go. Perfect. Now let's see if we can ping. Stinking router. Show IPv6. Okay, that's going to work. FD00. IPv6. Still can't pay it. What is going on here, man? So did that not get saved? No, it did not. Now what in the heck is going on with you? How do you have so many routes? Hmm. Wait a second, yeah. Oh wow. 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 That's funny. Ah, there we go. Wonder why I was running into so many stinking issues. Didn't have the friggin' interface on. That's funny. Oy, oy, Alright. IPv6, you give me a headache. It's already giving me a headache. Gig 00, right? Alright. IPv6 address. FD 00 colon 1 colon 1 colon 3. Gives everybody a damn headache. Thank you, Gamer Golf. Appreciate that. 0 0 1 2 3 4 5 6 7 8 /64. Shut. All right. Now I gotta give this. Let's copy this real quick. Okay. Copy. Put this route into our routing table now. Okay, let's do a do show v6 route. Okay. All right. Yeah. Yeah. Interface. We're gonna do the IPv6 routing interface gig 01. Right. P. Okay. That's it. Let's do a ping. What up, Prosper? How we doing, brother? Nice. Thank you for coming in today, man. Appreciate you, man. Are you gonna be streaming later on today, Prosper? Do ping. Let's ping that. Actually, let's ping router 1 real quick. Copy. I'll paste the. Nope. Let's. The interface is up, of course, buddy. I've been busy. Time just starting the new job. Not today, but tomorrow I'll be streaming Hitman 3. Hitman's such a fun game. Hitman's a super fun game, man. Let me see. Which one is 3? Trying to remember which one 3 was. Like, what was the story behind part 3? Is it the brand new one? Hitman 3 is super fun either way, man. You can do all kinds of goofy stuff on Hitman 3. Let's see if we can ping the other. Do ping E00 1 3 and it hits me. All right, so we can ping that one. Now let's see if we can ping the 2. We cannot ping the 2. All right, so do show IPv6 routes. Let's see if Browser 1 can ping the interface on R2, the FD colon 0 1 3 colon. All right, so there's one of our problems right there. What if we give it the 6 route colon 0 gigabit that same thing 6 routing /0 gigabit 0 Now let's try to ping again. Nope. It's not letting me, man. IPv6. Hurting my brain. Do show 6 interface. Brief. Do show 6 interface brief. Six interface brief. I can't even ping. Gig 0. They're both up on R2. So I can ping. What's crazy is I think I'm doing something fundamentally wrong. No, I am. So I can ping, FD 0, 1, 1, 2, 1. I can ping, so I can ping R2's interface this way. And then do ping FD 0, 1, 1, 3, colon, 1. I can ping F2's interface that way. But I can't. Oh, what am I fundamentally doing wrong? Dar, 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 dar. Each router. Oh, I know what it is. Stupid me. Darn it, man. 6 route art 3 yeah. Yeah, that's what I'm trying to. I'm setting. That's what I'm trying to do. I'm trying to set up routing protocol for it. Well, no, I did try to set up a routing protocol, but I biffed it on OSPF version 3, so I kind of gave up. I gave up trying to set up OSPF version 3 on it. There we go. Now, let's see. Now I should be able to do ping the 0, 3. What the heck is happening? You see how that, I've never seen that before. I have 2 successful pings, and then 2 failed pings, and then 1 good ping. All right. All right. So we did it. So that's that way.
Yeah, I've never seen this. Do you see that? See it? All right, let me go to my other screen. Because I made a zoomed in screen too for this. I've never seen that at all. That's the first time I've seen that. So that's pretty funny. All right, let's go to R2 now. All right, let's go to R3 and do this. All right, so that's going to be one, two. Now let's try do ping FD 0. These are directly connected routes anyway, so why did this work? Do show. Oh, can't even get to that yet. That's fine. Look at that again. That is so weird. I got 2 successful pings, but this time I got one. I got 1 successful ping. What am I breaking here? Ah. Let me do a do ping these 1, 2. Nice. So somehow I can ping router 1. So R2. R2. Let's say. All right, so that's it. Pinging 1. And that's it. Pinging 3. So R2 could ping 1 and 3. R1 now. R1. Let's try to bring R2's other interface. So that's FD. And there's that weird ping.
It's such a weird pin. You show IPv6 routes. Hmm. Yeah, I don't know. Epically weird. Epically weird. Let me do this. Let's do this. I'll put this thing down. Download the configuration. You work on that, buddy. Where you at? Things doesn't usually take this long to do this. So what I'm gonna do is I'm gonna download the configuration files and I'm gonna put it up on Git. Oh, then you guys can take a look at it and tell me where I beefed it. But tomorrow we're gonna be getting into tomorrow we'll be actually getting into the look of implementing IPv4 addressing on routers here. So compare and contrast IPv6 address types, global unicast, link local, anycast, multicast, modified, EUI 64. With IPv4 addressing, some devices like servers and routers typically use statically predefined IPv4 addresses. End user devices don't mind their address changes from time to time, and they typically learn IPv routes dynamically using DHCP. IPv6 version 6 uses the same approach with servers and routers and other devices in control of the IT group, often using predefined IPv6 addresses with end user devices dynamically learn IPv6 routes. So tomorrow we're going to be diving into the actually implementation. Like I said, this was like the first time. Let me capture this last device here. This was the first time I started implementing IPv6 in an actual network on network devices. So that I appreciate you guys sticking around and bearing through that painfulness. See, that one came back fast. Let me just make sure it's there. Now, Download lab. Let's get over to Git. Go add a file. Well, actually, I gotta rename that file because I didn't. Downloads. I'll rename. Six.
So again, if you get on my Discord, you can see that it actually just uploaded right now to my Discord server here. Let me go over to my other page. You guys probably didn't see anything I just did, right? Bloop. All right. So yeah, if you go over to my Discord and check it out, you'll be able to take a look at that configuration here in this lab. So, and again, it says first IPv6 lab. So that's the actual lab that we're working on. If you click on it, again, you don't need an account to get or anything like that. Yep. Good looking out, Gamer Golf. Yeah. So that invites. You just have to. One thing, once you go to the invite, you'll just have to read the rules and accept the rules and stuff like that to the Discord, and then make yourself over to the welcome page. And on the welcome page, you can assign yourself all kinds of roles and stuff like that for future notification stuff and stuff like that. Because I've broken up all the notifications, so not like most Discord channels where you get notified for every single thing. I broke that off where you can choose what you don't want to get notified on. You can choose not to get notified from anything, which is perfectly fine. I gave you guys that opportunity. Or if you want to just select certain things, like I got, like I said, I got network feeds in here where these I'm pulling off of Twitter, some feeds from a couple guys I follow. So Anthony Sequire, Kevin Baker, my main man David Bumble, Nick Russo. Nick Russo is an awesome cat. If you guys have never followed anything Nick Russo, he's an awesome dude, man. He's super smart. He's a former Marine too, man. He's hardcore. ITT Pro TV and stuff like that. I also got Kevin Wallace. He doesn't use Twitter that much, but I follow him on Twitter too as well whenever I get his stuff. But also, when any of these guys drop their YouTube videos as well, guys, you guys can choose to get notifications on that as well. I got my Goose's Corner for my Gooses out there. If Prosper's still in the chat somewhere, I got some of my Gooses in there. And then if you guys stream yourselves, I got a little promote your own stream too, guys. And then I have a Reddit column where some of the Reddit feeds that I follow that you guys can take a look at and stuff like that. I built this Discord for like a portal for things networking and stuff like that. So take a look at it, guys. Tell me what you think. You know what I'm saying? I got a little suggestions box over here, guys, that if you guys have any suggestions for the server at any time, guys, just drop something in there and tell me what you guys think and stuff like that. So again, if you want to check out that lab we just did, you just go right over here to the Cisco Model and Lab tab. All right, and you'll see it. It'll say the first IPv6 lab. Again, you don't need an account on Git. That's why I did this, because you don't need an account for Git. You don't need to download a YAML file, nothing like that. You simply just click on that. Obviously, it's going to take you to the Git page, but you're going to be able to actually look at the text file itself without having to download nothing. you can just look at it. You can just see it actually right on the Git page itself, guys. So that's why I did it in this fashion right here. All right, all right. So we got that. Again, tomorrow again this time, 5:30 p.m. Eastern Standard Time, we'll be getting into Chapter 4, implementing IPv6 addressing on routers. So this should enlighten me. This should elaborate on some of probably some of the things that I was biffing on tonight. But I just wanted to do it tonight, just so tomorrow when we actually do it, I can be a little bit more prepared and a little bit more adjusted to how to implementing and just be be more comfortable with implementing IPv6 on an actual router. All right, and then again I'll send you that lab right on Git again, guys, so you guys can take a look at it again. All right, and then pretty much from there, let me see. So implementing IPv6 on addressing on routers, and then chapter 25, implementing IPv6 routing. So this should help us create some of those static gateways and whatnot. Okay, all right, and then that's going to end this IPv6 part, guys. But again, I owe you guys a stream, so I owe you guys Saturday as well. Normally on the weekends I stream sometimes, but I definitely owe you guys a stream for Saturday because of yesterday. Okay, I just wasn't feeling very good. Obviously we're working too much, and I was just totally out of it, and I kind of felt I wasn't going to be able to give the stream, and I just wasn't going to be able to pay attention to what I was doing. So I had to cut it short yesterday. So I owe you that. So we have a makeup day. That makeup day will be this Saturday. All right, so we'll dive into things then. Oh, I know, Gamer Golf, I know. But because I know exactly, and thank you very much, Gamer Golf. I appreciate that, man. That makes me feel good. What I guess what I'm trying to do with this whole channel is I really want to be as consistent and as on timely as possible. Because I look at this stream, I take this stream very, very. I put so much into the stream, and I take it very serious. As much as I try to be goofy and stuff like that. I try to do that just to take it, to be a lighthearted about all this studying, because this studying can get dry sometimes. But I do take this stream very seriously, and I've invested so much of my time, so much work. Like I've been trying to improve upon, and that's another thing too, guys. If you guys have any comments on how to improve this as well, please tell me on how to improve this, guys. And thank you, Gamer Golf, man. Thank you so much, man. But yeah, that's the only reason why I guess I say that, because I look at this stream as a part of my as part of my career almost. And that's why I say that. So, but that's kind of it for now, guys. So let's do this. Let's see who's on Twitch right now. Let's see. Let me change my stations real quick. Play some music here. That being said, we'll happily take extra content streams if you're willing to put it. Thank you, Gamer Golf. I appreciate that, man. You're the man, Gamer Golf. I really appreciate your time. You're an awesome dude, man. Let's go. Who should we raid today? Who should we raid today? Who should we raid? All right, let's go. What if I rating?
let's go. Yeah, if you guys never bet Bruce Green, we're gonna actually go raid Bruce Green. He is the father of the gooses, guys. The father of the gooses. We're gonna go say hi to Mr. Bruce Green, and we're gonna go show him some love. You guys have a great night. I love every single one of you guys. Thank you again for joining me, Gamer Golf. You're awesome. And I'll talk to you all guys tomorrow. All right. Let's go say hi to Bruce Green.
Very much, Little People, for gifting 10, Hypersonic for gifting 5, Revelance for gifting 10 more.